is about file system in operating system. So this is a directory architecture of a file system. For example, there will be a root directory, and inside the root directory there will be subdirectories, and we will be storing our files inside this subdirectories. So a typical example for this is when we are saving our C programs. So for example, C will be the root directory, and inside the C there will be a TC subfolder, and inside that there will be another subfolder bin. So we will be saving your files inside the bin directory. So this will form a directory like architecture. And the next is storage. So how the files are storage? So in the form of disk. So inside the secondary storage device such as disk, our files are stored. So each device, each disk will have different types of sectors. So this will form a cylindrical architecture, and inside the sectors there will be different types of blocks. So these blocks will be having some typical length, and the files will be stored inside these blocks. So there will be read and write head for these blocks. So this is an architecture of a disk where the files are stored. So when coming to the file system into two phases, that is user level and the OS level. So when coming to the user level, the user can have only three privileges. For example, an user can set the access method for the file. For example, whether the file is a read file or read only file or read write file. So like this we can set the access methods. And the second one is we can set a directory structure. That is, as in the previous slide, we will be saving our files inside a particular directory, and inside that we will be storing all our things. So this will be a directory structure. And the third level for a user is he can set a protection for his file. For example, we can encrypt our files, or we can set the passwords for our files. So this is a protection method. So these three components will come under the user level portion of the file system. And when coming to the OS level, what is the primary goal of an OS when coming to the file system? That is, the OS should allocate the space for our file, and it also should allocate the free space management inside the disk, and it should also implement the directory inside the file system. So the OS is having all these duties, that is allocation and free space management and the directory implementation. So these work will be done by the OS. The user is having these three privileges, and the OS has to do all these things inside a file system to store our file. And then this is a file system structure. This is a simple file system structure. That is, when starting from the application program, and the next level is logical file system, at which the user can request the file operation by system calls. So we know that the operating system can communicate only through the system calls. So there are different types of system calls. The popular one is fork and join. So we all know that the kernel level system or the user level mode has to communicate only through the system calls. So these logical file system will make the users to request the file operations by system call. And then the next level is the file organization module, and the next is the basic file system, and the next is the IO control operations and the devices. So this is a typical file system. The file system resides on the storage disk, that is the disk. So this can be organized into levels from the lower level to the higher level, and each application program and the logical file system and all the levels will be having a control block. So that is, this is a detailed architecture. That is, the file system is organized into layers, and the logical file system manages the file system structure, that is the directories and the file control blocks. So each block is nothing but a table where it stores all the information about a file. So what will be the information about a file? Every file will have a unique ID and the storage location and the subdirectories details and the creation time and how the file and the properties of the file. So like this, every file system will have all the informations, and the file organization module which maps the logical blocks with the physical blocks. So there will be a free space manager. So in the free space our files will be stored, and this basic file system will have all the
several on disk and in-memory structures are used to implement a file system. So boot control block, volume control block and file control block. These are the blocks that is maintained on the storage disk to store the information for the file system. For example, boot control block will store all the information related to the booting of the operating system, and the volume control block will store all the volume details, and the file control block will store the information about the file such as the type of file and the created date and the size of the file and who is the owner of the file. These things will be stored in the file control block. Block is nothing but a table which can store all the informations. So when related with the disk, these things will be stored, and in the in-memory structures, so the in-memory informations for storing for the file system or the storage management is the in-memory partition table, the in-memory directory structure, the system-wide open file table and the per process open file table. So these informations will be stored related with the memory, and these things will be stored related with the disk. These things will be stored related with the memory. So like this, these informations will be useful for storing a file in a file system, in an operating system. And the file control block will contain all these informations, file permissions and the date of the files and who is the owner of the file and the file size and how the data, what are all the data blocks for a file, are the pointers to a file data blocks. So these things will be stored in a file control block. And when we are opening a file, for example, if a user is opening a file, so what is happening in the kernel? So when a user give a open file command, so the directory structure in the kernel will look like this. For example, as I told you earlier, that if it is a C program, it will have a directory structure as C:/tc bin. So C will be the root directory and TC will be the subdirectory and bin will be another subdirectory. So these things will be stored in the kernel's memory, and the kernel will relate to the secondary storage, that is the disk, through these directory structures and the file control blocks. And when the user is giving a read command, so it will look at this per process open file table in the memory, and using that index number it will go to the system wide open file table, and using that index number it will go to the data blocks and search for the file, and it will fetch the particular file control block and it will give to the user. So this is the way how a open file is how opening a file is working and how a reading a file is working from the user to the secondary storage. From the storage the file is fetched to the user. So like this, all the memory file structures and the directory structures and all the disk informations are used to retrieve a file and also to store a file in the secondary storage. So this is a memory file system structure, and again this is also a memory file, the same diagram. So what is important here is using the read and write system calls and using the file handler to locate the file, and it is the read and write operations and the system calls are used to send information from the user to the kernel and from the kernel to the storage memory. So like this, the system calls are used. Here file handle, that is descriptor, refers to the index. The index is nothing but the descriptor. It is referred as the index. So like this, this full architecture is working. Like this, we can read a file and we can store a file through the kernel in the operating system. And this is the entire structure for partitioning and mounting the file system. For example, this is a partition system. So for imagine that it is a Linux system. So in the Linux system, the root directory will be subdivided like this. How the file is partitioned in the disk? Usually the secondary storage device will be partitioning the entire file system. Like our system is having C:, D:, and E:, we are partitioning our system as C:, D:, E:. In the same way, the secondary storage devices are partitioning the entire file system. So inside the partition B, there are some files. This partition B is mounted to the home directory. So like this, this partition C may be mounted to the root directory. Like this, it will partition the entire system and it will also mount the file system. So this is the partitioning and mounting a file system, pictorial diagram of how to partition the files and how to mount the files. For example, imagine that this is a Linux system. So inside that home subdirectory, all the information about the Linux file system, how the Linux file system is storing the root file system in one partition, and the remaining files in the second partition, and the remaining projects in the next disk. So like this, the disk can be, there may be many number of disk and there may be many number of partitions, but as a whole it will give an illusion to the user that all the systems are stored in one place. But in the disk it is stored in different places with different partitions. That is the representation of this diagram. And the next is mount table. You know that this mount table is used to store all the informations about the mounted files to be stored in the file, and the directory structure about the directory information. And the next is one question arises in operating system is that how it is supporting multiple files in one place. So with the help of the virtual file system interface, or it is an API, this file system is managing all the files of different types from different disk. So local file system type 1, this may be of one type, and in this disk there may be another type of files, and in the network there may be another type of files. So it is managing this virtual file system interface, or it is an API which was designed in object oriented language. So it is using all these, it is implementing all these files into one, it is grouping all these files into one module, and it is helpful for the file system interface. Again, this is the same diagram. This virtual file system, it is using the object oriented techniques to simplify and modularize the implementation. So this is nothing but an API which is used to store different types of files, and it allows different types of files with a unique identifier, and it is represented throughout the network. So this virtual file system helps the operating system to be integrated, to integrate multiple files into a simple single directory structure. So this is the help of Linux virtual file system. So it is communicating through the system calls. So through the system, imagine that there may be many systems, and many systems can be mapped with the root directory, and it is a secondary storage disk. So there may be many systems but all the virtual file system is helpful to communicate throughout the system through the system calls. So it will, this Linux, every operating system will have a different virtual file system. This Linux virtual file system, it is communicating with the system X, say system X, through the system calls, and through the system calls the files are stored in the secondary storage device. So this is an example for a Linux virtual file system file system concept. And the next is how this programming, this object oriented programming virtual file systems are stored in the operating system, how this programming coding is developed. That is the thing here. Here the linear data structure concepts are used for writing the program codes. Here the linear list and the hash tables are used. This linear list, you know that it will have a list like structure, and it will have a pointer to communicate between the list. And this hash table, it is also a data structure. It is used in mainly, imagine that this hash table is used for dictionaries. So in the dictionary we will be going to search for a word. So this hash table architecture will be helpful to find the search very easier. So inside the directory, this hash table data structure is used. So this will increase the decrease the directory search time, and it will also avoid the collisions between the two file names in the same location. So this linear list, this data structure will be simple to program, and it will be also time consuming to execute. So by in the operating system, the coding is done using these two data structures for directory implementation. So this is a diagram of a linear list. You know that there will be a list, so it will be interrelated with the second list. The list will be going on. There will be a pointer. So this pointer refers to the data blocks in the file system. And the next is inside this linear list, this hash table is attached with this. You know that a hash table will have a key and also a value. Imagine that in a dictionary, you will be, for example, if you are going to search for a word computer, and you will be searching it with, first letter C, and the second one is COM, and the third key value will be computer. Allocation methods. The allocation methods define how the files are stored in the disk blocks. So the main idea behind these methods is to provide efficient disk space utilization, that is to manage the free space management, and to allocate fast access to the file blocks. So these are all the main idea behind these methods. So generally there are three allocation methods: contiguous, linked and indexed. So in the older days contiguous methods were used. So before that we have to know about the types of files. For example, sequential file. So this is a diagram for a sequential file, that is the blocks will be sequentially arranged from the start to the end of the file. So this is one way of allocating a file. This is sequential file. And the next is this is a diagram of a hard disk. Here the hard disk is separated into sectors, and each sector is having 512 bytes. Here the blocks will be allocated sequentially like this. So the entire file will be allocated like this, partition like this, and it will be stored in the hard disk. This is another access method. And the next method is indexed and relative method. So in the indexed and relative method, for example, here Smith is a record which is relatively indexed with the John file. So here the Smith is related with this John file. So this is one way of indexing the file, and when it is related with John, this is known as a relative file. So this is another access method. So sequential method, this one index file, and the relative method. Now again coming to the allocation methods. So the contiguous allocation method, linked and the indexed allocation methods. So in the contiguous allocation method, it will assign consecutive memory blocks. That is, consecutive memory block means a file will be stored sequentially, that is 0 and 1, 6 and 7, and 14 and 15 and 16. And then this one 19 to 23 is consequently allocated memory block. So like this, the consequence of allocated memory blocks is known as contiguous allocation method. So in the directory it will be stored like this. So the file, the name of the file, and the starting position and the length position. Like this, sequentially it will be allocated. This is contiguous allocation of disk. And the next one is again indexed allocation of disk. Here there will be an index. So the files will be looking up to this index table, and in the index table the information about the blocks will be stored, and the directory will be given an index block 19. Here using this index block 19, this will have a table and it is representing all the blocks. So this is the pointer like structure. The index will act like a pointer. It will store the address of all the remaining files in the indexed allocation block. So this is one way of allocation scheme. And the third one is the relative scheme. So the relative scheme will be similar to that of the indexed file allocation method. That is, in the relative file system we have seen that is a relative linked allocation scheme. So these are all the three allocation methods we are having in the file system in a OS. So this is a relative allocation file. So like this relative files will be stored. So the indexed and the linked will have a pointer to represent the files. So with this I am ending this file system chapter. So the remaining we can see in the next lecture. Thank you.